Hello friends, I'm Swapna Shetty. In this video, we are going to discuss about deadlocks. So before knowing what is a deadlock of threads, let us take an example to understand what is deadlock. So even if we synchronize the threads, there is a possibility of other problems like deadlock. So for example, daily thousands of people book tickets in trains and cancel tickets also. If a programmer is to develop code for this, he may think that booking tickets and canceling them are reverse procedures. So he write these two tasks as separate and opposite tasks and assign two different threads to do these tasks simultaneously. So to book a ticket, the thread will enter the train object to verify that the ticket is available or not. When there is a ticket, it updates the available number of tickets in the train object. So for this, let us say it is taking around 150 milliseconds. Then it enters the compartment object. In the compartment object, it should allot the ticket for the passenger and update its status to reserved. This means the thread should go through both train and compartment objects. Similarly, if a thread has to cancel a ticket, it will first enter the compartment object and updates the status of the ticket as available. For this, let us assume it is taking around 200 milliseconds. Then it enters the train object and updates the available number of tickets there. So this thread also should go through both compartment and train objects. When the book ticket thread is a train object for 150 milliseconds, the cancel ticket thread will be a compartment object for 200 milliseconds. Because we are using multiple threads, we should synchronize them. So the threads will lock those objects. When 150 milliseconds time is over, book ticket thread tries to come out of the train object and wants to lock on compartment object by entering it. At that time, it will find that the compartment object is already locked by another thread, that is cancel ticket, and hence it will wait. So book ticket thread will wait for compartment object for another 50 milliseconds. After 200 milliseconds time is up, the cancel ticket thread, which is there in the compartment object, completes its execution and wants to enter and lock on train object. But it will find that train object is already under lock by book ticket thread, and hence it is not available. Now cancel ticket will wait for the train object, which should be unlocked by book ticket. In this way, book ticket thread keeps on waiting for the cancel ticket thread to unlock the compartment object, and the cancel ticket thread keeps on waiting for the book ticket to unlock the train object. So each thread is expecting the other thread to release the object first, and then only it is willing to release its own object. So both the threads will wait forever in this way, suspending any other further execution. So this situation is called thread deadlock. When thread deadlock occurs, no execution will be done and the program will come to a halt. So thread deadlock is a drawback in the program. So the programmer should take care to avoid any such deadlocks in the programs. So let us write a program to understand this example. So I'll create a class called deadlock within the package com.educators with the main method. So before writing the main method, I require two threads. One is book ticket and the cancel ticket. So class book ticket extends thread. So in which first I write two objects here, that is train and compartment. So train comma comp compartment, and I take a constructor, generate constructor using both the fields. So it is saying object type and this dot train equals to train and so on. So I initialize the objects by using a constructor, then I need to write a run method. So in this run method, first I need to lock on train object. So for that I use synchronized block, that is on train object. So first I would just print that book ticket logged on train. And now I will assume that it would take around 150 milliseconds. So since I'm using sleep method, I need to surround it with try catch. And next, I would say now book ticket will be waiting. That is system.out.println book ticket now waiting to lock onto the compartment. Ticket now waiting to lock on compartment. It is still waiting. So now when it gets the lock on compartment object, I need to synchronize it based on compartment object. So when it gets the lock, now I would just print that book ticket logged on compartment. So this is a book ticket thread. Similarly, I need to write the same way the cancel ticket thread also. Cancel ticket extends thread. Here also I have both the objects, train and the compartment. The same way I need to initialize using a constructor. I need to write a run method. So first cancel ticket needs a lock on compartment object. So I write a synchronized block on compartment object. When it gets the lock, I just print now cancel ticket logged on compartment. After getting a lock on compartment, I'll wait for, so it is taking around 200 milliseconds. So sleep method will throw an interrupted exception, so handle it. After handling it, now it cancel ticket. After waiting, it has to wait for lock on the train object. So I'll just print that message. So cancel ticket. Now waiting to lock on train. So when it gets the lock on train object, that is synchronized block on train object, I would just print now that cancel ticket is logged on train. So both the threads are just doing their work when as they get their objects on the locks. So in the main method, first is we need to take this train compartment as objects of object class. So for that I create an object to the object class object train equals to new object. Similarly, object compartment equals to new object. Next is we need to create objects to book ticket and cancel ticket classes. So for that, book ticket of bj1 equals to new book ticket of train and compartment is same. Similarly, cancel ticket also. Cancel ticket obj2 equals to new cancel ticket of train and compartment. So both the objects to book ticket and cancel ticket. So here the object name is compartment, so I need to pass the whole name compartment. So after creating objects, now I need to attach two threads to these objects. That is thread T1 equals to new thread of attach the obj1, that is book ticket. Similarly, thread T2 equals to new thread of obj2. Attach both the objects to the threads. Now run the threads on the objects. That is T1 dot start and T2 dot start. So book ticket is a thread which is having both train and compartment objects. First it is locking on train and waiting for 150 milliseconds. Then again it is waiting for lock on compartment. When it gets a lock on compartment, then I'm just printing that it's locked on compartment. Similarly, cancel ticket also, first it will get a lock on compartment and then it will get a lock on train. Now let's run this application. So we have seen that book ticket thread and cancel ticket thread acts in reverse direction, creating a deadlock situation. So if you observe the output, here you can see the red mark. It is still not terminated. The program is still not terminated. Book ticket thread is waiting for the compartment object, and similarly cancel ticket thread is also waiting for the train object. So this situation continues forever. So this waiting continues forever. So this situation is nothing but it's a deadlock. So how to avoid deadlock? There is no specific solution for the problem on deadlocks. It depends on the logic used by the programmer. So he has to design his program in such a way that it should not get or he should not form any deadlock. So for example, in this program, if the programmer used the threads in such a way that the cancel thread follows the book ticket, then we would have avoided the deadlock situation. So for this, we change the code in the cancel ticket class so that it also follows the same sequence like book ticket thread. First of all, book ticket will enter the train object. After it processes the object, it comes out and finds the compartment is freely available. So it enters compartment object and finally releases both the objects and comes out. Till then, cancel ticket thread will wait and finally, and once book ticket comes out, the cancel ticket thread also follows the same sequence. So there will be no any deadlock. So what change we need to make here is run method inside the cancel ticket should be changed. That is, instead of locking on compartment first, we would follow the same sequence as book ticket. That is, wait on train first and then the compartment. So terminate this and just say clear and run the application. So first you can see book ticket, logged on train, then it waiting for the login compartment, then it's once it gets a login compartment, it logged in compartment. Then only cancel ticket entered. First it logged on compartment, then waiting to log on a train, and then it logged on the train. So this is how we can avoid the situation of deadlock. So what is deadlock? When a thread is waiting for an object lock that is acquired by another thread, and the second thread is also waiting for an object lock that is acquired by the first thread. So both the threads will continue waiting forever. So this is nothing but thread deadlock. So we have thread priority, which ranges from 1 to 10. We basically have three constants called min priority, norm priority, and max priority. All are of public static int. So min priority has got a default priority or default number of 1. Norm priority has got 5 and max is 10. So that's all with the video session. Thank you.